Hello everyone, this is Sahiti on behalf of Edureka and I welcome you to this session on Kubernetes Dashboard. So thank you all the attendees for joining in today's session. Before I get started, all of you just give me a quick confirmation on the chat window whether I'm audible or not. Alright, I've got many yeses. Alright, so that's great. So now let's get started with the session. So without wasting any further time, let me tell you what all are we going to discuss for today's session. We're going to discuss all about dashboards, that is the different components of dashboards, where is it used, how is it used, how can you create the deployments, how do you create services, how do you connect them, everything. So you'll understand all about the components of dashboard. Well, let me tell you that the dashboard is a web-based Kubernetes interface to deploy containerized applications to a Kubernetes cluster to troubleshoot your applications and also manage the cluster itself along with the attendant resources. So you can use the dashboard to get an overview of the applications running on your cluster as well as creating or modifying individual Kubernetes resources such as deployments, jobs, daemon sets, and many more. So you can scale a deployment or you can initiate a rolling update or you can even restart a pod or deploy new applications using a deploy wizard. So in this session, we will look into deploying the dashboard UI, accessing the dashboard UI, understanding the welcome view, and also deploying containerized applications using dashboard. Now, if you have to deploy the containerized applications using the dashboard UI, you first have to deploy the dashboard, right? So for that, you'll have to first initialize your cluster services and then only you can deploy your dashboard UI. So let me show you how that is done. So let me go to my KMaster node. Let me open a terminal. So to initialize the Kubernetes cluster services, you have to type in this command and then you have to mention the IP address. Once that is done, you can see that it is initializing the cluster services for you. All right. Now you can see that your Kubernetes cluster services have been initialized. Now to join your K node to this cluster service, you have to just copy this particular token and then you have to paste it in your K node, right? So we'll go to K node, we'll open the terminal, and once you open the terminal, you have to first get the super user access. So for that, you'll again type in sudo su and then you'll paste the token over here. Now, as you can see that there's an error that has happened. That's because our cluster was already initialized for Knode. To undo that, you have to type in the command kube adm reset. And then you'll choose that yes, you're sure to proceed. Once you're sure to proceed, it will delete all the files and all the stuff that you've done on this particular node. Then you have to reinitialize this node. So for that, you'll again place the token. You'll paste the token and then you can see that the node has been initialized. So by this, we're joining the cluster services with a particular node, right? So guys, that's how you can initialize your cluster. Now coming back to the KMaster node, you have to create the config file so that, if you want to execute them as a non-root user, this will enable you to use the kubectl from the CLI. Let's just do this. I'm making a directory and then I'm pasting all that is present. Now, to verify if the kubectl is working or not, you have to run a command that is kubectl get pods -o wide - all namespaces. So let me just mention the command. When you see the output, you can see that all the pods are running except the DNS one. So to resolve this problem, you have to enable the Calico network. So for that, you just have to mention this command. And once you mention this command, you can see that, all the Calico extensions have been created. Now let's just check once again. So for that, I'll type in again the command. So you can see that our problem was resolved and all the extensions and the required nodes are working. Now to deploy the dashboard, you have to mention a command. So let me just mention the command. And you can see that our dashboard has been installed. So you can see in the output file that, dashboard has been created and it has all the deployment files that it needs and everything is there. But there's one thing here. Now by default, the dashboard will not be visible to the master VM. So to make it visible, you have to run the command kubectl proxy. So let's mention that. So by typing this command, you can see that our dashboard has been enabled for the master VM also. Now, once you're done with that, make sure that you open a new terminal and you do not close this terminal while you're working on the dashboard. So guys, that was how you can deploy your dashboard UI. Now, how do you think that you can access the dashboard UI? Well, there are mainly two ways that you can access the dashboard UI. That is either by using the kubectl command line interface or by accessing the Kubernetes master API server using your web browser. So in this session, I'll be mainly focusing on the command line interface, that is by using the kubectl commands. So as I was telling you that we will be focusing more on the kubectl commands. Since I've already used the command kubectl proxy, my dashboard is accessible by the master VM, and therefore kubectl will handle the authentication with the API server and make the dashboard available at the local host with its allocated port. So let me open my web browser and then let me show you my dashboard. Alright guys, so as you can see on the screen, this is the first page of your dashboard where you have to create your token or kubeconfig, where you're asked for the option to create your own token, that is basically your service account. So let's start by creating the service account for the dashboard and then get its credentials. So to first create your service account for the dashboard in a default namespace, you have to type in the command kubectl create service account dashboard -n default. Once you type in this command, you can see that your service account has been created for the dashboard. After that, you have to add the cluster binding rules to your dashboard account. So for that, you'll have to mention this following command. Now, once you have created a service account for your dashboard and you have also added the cluster binding rules, you will need a token to log into your dashboard. So to get a token, you'll mention this command. So once you type in this command, you can see that your token has been generated. Now just copy this token and then paste it on your dashboard. So let me just copy this token and then let me go back to my dashboard and then choose the token option. Then I'll remove this already existing token and then I'll paste the token generated. Once you enter the token generated, click on the sign in option. So once you click on the sign in option, you can see that your Kubernetes dashboard opens up. You can just click on don't update or update password. So I'll click on update password to update my password. So as you can see that this is your Kubernetes dashboard. So on the left side, you have all the options, that is clusters, workloads, pods, nodes, replica sets, discovery loading, config and storage, and all the options. So all the options that you need to configure your pod or your networks and your communications between them are on the left side. So when you come onto your dashboard for your first time with an empty cluster, you'll see the welcome page. So this page contains a link to the document as well as the button to deploy your first application. So talking about the first application, how do you think that you can deploy your first application? So well, that can be done with three options. But before that, let me show you from where. So you see this plus sign with create, right? So that's the option from where you can deploy your applications. So let's deploy a particular application and then let me tell you what all are the ins and outs for deploying an application. Okay, so let me click on the create option. So once you click on the create option, you can see that you have three options. That is either you create from the text input, or you create from a file, or you create an application. Now anybody coming to the dashboard for the first time goes for creating an application, as it has options to specify all the required configurations. Create from a text input is where you already have a YAML or a JSON file specifying all the resources to deploy the currently selected namespace. And then if you have to create from a file, this option is generally chosen where you already have the YAML file with all the specified resources already on your local repository, and you just have to choose that YAML file. So these are the three options. So let's deploy our first application using this option. So we have various parameters that you have to understand when you start creating your containerized applications. So starting with the app name is basically the name of your applications. So it's basically a label name with which the name will be added to the deployment and service, if any, that will be added to the deployment and service if there are any to be deployed. The application name must be unique within the selected Kubernetes namespace, and it must always start with a lowercase character and also end with a lowercase character or a number, and it should only contain numbers, letters, and dashes. No other characters are allowed apart from these, and the maximum limit of characters that it can have is 24. So let's say I mention the name as Edureka hands-on. All right. And then coming to the container image. So container image is basically the URL of the public Docker container image on a registry or a private image which is hosted on the Docker Hub or a Google Container Registry. So let me type in the container image. So suppose I type in Nginx container. Now coming to the number of pods. So the number of pods is basically the target number of pods that you want your application to be deployed in. So it's a layman fact that it should always be a positive number. So it can be any number of pods, right? So suppose I give 2 pods. So I'm giving it 2 pods. Now, once you've mentioned the number of pods, you have the service. So when talking about the services, there are 2 types of services, that is either the internal service or the external service. So for some parts of the application that you may want to expose a service onto an external, maybe a public IP address, then you will need an external services. Now, to expose a service onto the external IP addresses, you may need to open up one or more ports. Now, let me choose a service type here. So suppose I'm going for the external service, and then I'll mention the port number, the target port, and the protocols. So suppose I mention the starting port number to, let's say, 80, to the target port to be 82. So it can be anything that you want to mention. And the protocol has an option for TCP and UDP. So let's say I choose the protocol to be TCP. So similarly, you'll have to do it for the second port also. So let's say I start the second port on a different port and have a different target port. So let's say I have a different target port with again the protocol to be TCP. Now once you're done with that, these are just the basic options that you can choose for. You can also have the advanced options. So let me go to this tab, show advanced options, and let me show you what the advanced options offer. So here the first thing that you see is the description. Now description is basically any text that you enter as an annotation to the deployment, and it will be displayed in the application's detail. So you can say that this particular application is for some particular deployment or some particular communication or anything like that. So let's say I enter a text saying that this is for hands-on, and then enter the description. Then you can go for the labels. Now the default labels to be used for your application are the application name and version. You can specify the additional labels to be applied to the deployment service, such as release, environment, partition, release track, tier, etc. Suppose it is a front-end application, you can mention the tier to be front-end, and if it's a back-end application, then you can mention the tier to be back-end. So you can do that, and then once that is done, you have namespace option. So as it is a known fact that Kubernetes supports multiple virtual clusters backed by the same physical cluster, these virtual clusters are nothing but the namespaces, and they let you partition resources into logically named groups. So Dashboard offers all the available namespaces in a drop-down list and also allows you to create a new namespace. Now, let me tell you one thing here. The namespaces may contain a maximum of 63 alphanumeric characters and dashes, but it cannot contain the capital letters. Also, the namespaces should not consist of only numbers. If the name is set as a number such as 10, the pod will be put into the default namespace. In case the creation of namespace is successful, it is then selected by default, and if the creation fails, the first namespace is selected. Right? So that was about namespace. After the namespaces, we have the image pull secret. Now, image pull secret is basically it gives you the credentials from where you're pulling a Docker image. So suppose any container image is already published on Docker Hub and you just want to pull that particular image, you mention the credentials here, right? So Dashboard offers all the available secrets in a drop-down list and allows you to also create a new secret. Now, if you want to create your own secret name, then you must follow the DNS domain name syntax. The content of the secret must be also base64 encoded and specified in a Docker FG file. Not only this, but the secret name may consist of maximum of 253 characters. So in case the creation of image pull request is successful, then it is selected by default. Else, if the creation fails, then no secret is applied unless you want it to be applied. Okay. So that was about the image pull request. Next, you can see the CPU requirement and the memory requirement. So this is basically the minimum resource limits for the container. After the CPU requirement codes, we have the run command and the run command arguments. So by default, your containers will run on the specified Docker images deployment entry point commands, and you can use these command options and arguments to override the default. Now, after that, we have a checkbox that is run as privileged. So the setting basically determines whether processes in privileged containers are equivalent to the processes run as privileged. The setting basically determines whether processes in privileged containers are equivalent to the processes running as root on the host or not. The privileged containers can make use of the capabilities like manipulating the network stack and accessing the devices. And over here, we finally have the environment variables. So Kubernetes exposes services through environment variables. So you can compose environment variable or pass the arguments to your commands using the values of environment variables, and then they can be used in your applications to find a service. Alright, so guys, that was all about this options. So once you're done configuring all the options as required, you just have to choose this option deploy. Now, once you click on the deploy option, you can see that your application has been deployed. So this redirects you to this page where you can see all the workload statuses that are running. So 100% deployment because our deployment is successfully done. We have all the pods running with all the replica sets. So you can see that our Edureka hands-on deployment is working. Since we mentioned two pods, so we have two pods and the required configurations. And over here, we also have the replica sets and the services. So with the help of dashboard, you know what all services are working, what are not working, you understand all about it. Now, as I was talking about the other two options, let me brief you about the other two options also. So I'll be talking about create from file option. So Kubernetes supports declarative configurations. By this, I mean that all the configuration is supported either by the YAML or the JSON configuration files using the Kubernetes API resource schemas. So as an alternative to specifying application details in the deploy wizard, you can define your application in YAML or JSON files, and then you can upload the files using this dashboard. And finally, we have create from text input. So talking about the create from text input option, what you have to do is you have to mention all the required configurations over here, and then the dashboard will automatically take these configurations to deploy your application, right? So that was about these three options, guys. As now you have understood how to deploy your containerized applications, let's talk about views. So as I was talking about views, the different type of views that we have are the admin view, the workloads view, the services and discovery view, the storage view, and the config view. So starting with the admin view. So admin view is basically for the view of the clusters and namespace administrators. It lists the nodes, namespaces, persistent volumes, and has details views for them. The node list view contains the CPU and the memory usage metrics aggregated across all the nodes. The detailed view shows the metrics for a node such as the specifications, status, allocated resources, events, and pods running on that node. Next coming up view is the workloads view. So the workload view is basically the entry point view that shows all the applications running in the selected namespace. The view lists applications by a workload. It shows kind of the deployments, pods, replica sets, stateful applications, stateful sets, etc. So as you can see on my dashboard, it has all the deployments, the pods, the replica sets listed, and so on, right? So this list summarizes the actionable information about the workload, such as the number of ready pods for the replica set or the current memory usage for a pod. Not only this, but you can also scale the number of pods working. So you just have to go to this three dot option that you have in the deployments. Then you have to choose the scale option. And then over here, you can mention the number of pods. So you can mention the desired number of pods. So the current status presently is that two are created and two are desired. So let's just say I just want one to be desired more, and I'll click on OK. So as you can see that, we have reduced the number of pods from 2 to 1. So that's how you can upscale or descale your number of pods working. Now, detailed views for the workloads show status and specific information and surface relationships between the objects. So for example, pods that replica set is controlling, or new replica sets and horizontal pod autoscalers for deployments. So guys, that was all about the workloads view. Now the next view that we have is the service and the discovery view. So the services and discovery view shows the Kubernetes resources that allows for exposing services to the external world and discovering them within a cluster. So for that reason, services and ingress views show pods targeted by them and the internal points for the cluster connections and also the external points for external clusters. So as you can see on my screen, Edureka hands-on has a cluster IP address, which is the default service type, and it also has the resource configurations of the internal endpoints. Now, coming up to the next view, that is the storage and the config view. So the storage view shows the persistent volume chain resources which are used by the applications for storing data. And coming to the config view shows all the Kubernetes resources that are used for live configuration of applications running in the clusters. This is now the config maps and secrets that I'm talking about. So if you go into the secrets, you can see when was the token created. So this view allows for editing and managing all the config objects and displays the secrets hidden by default, right? Now coming to the config view, as I was talking about, the config view shows all the Kubernetes resources that are used for live configuration for applications running in the clusters. So this is now basically the config maps and the secrets that I'm talking about. So this view allows for editing and managing the config objects and displays the secrets hidden by default. So by secrets, if you remember, I'm talking about the tokens that were generated, right? So guys, that was all about the Kubernetes dashboard. So as you just saw, you have all the options to configure almost anything that you want to, enable your application to do. So you can configure the daemon sets, deployments, pods, jobs, replica sets, and all the Kubernetes concepts that you understand can be done practically over here. So I would say that dashboard is a really easy way to configure all your stuff, and you know what all stuff that you need because it gives an explanation whether it is needed or not. So that was all about the Kubernetes dashboard. This was just the basics about Kubernetes dashboard. If you want to learn more and you want to get an expertise in Kubernetes dashboard, then you have to explore this dashboard all by yourself and try deploying many applications in Kubernetes. Okay, so that's all for today's session. I hope you found this session informative. Thank you and have a great day.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!